Welcome to this month's edition of the HazMatIQ Chemical of the Month. We're going to do something a little bit different today. We've just developed our most recent set of charts. These are going to be called version 20. Version 20's got some pretty radical changes from the older charts. But, you know, if you have only the old charts, surely they'll still work. But we want to just show you and highlight some of the changes. And so probably if you see these, the first thing you'll see that's so different is we went from, instead of having 3 two-sided charts, we now have 4 two-sided charts. And we've added a little something to each chart to enhance it to even make it better.
So, I mean, the system stays the same. So just think about if you're on a football team and you get a new coach. We're just changing, you know, the playbook. It's still the same game. It's still
so if
the
you
same
say
hazards.
red 3,
it's the
it
same
works
thing.
on all charts.
Right.
Red 4 works on all charts.
We're not changing the playbook or nothing. It's a new coach with a new playbook that is a better playbook, but it doesn't take away from the game. Still,
you know, for instance, if you look at chart number 1, what did we do differently? Well, we got a lot of input from students that said, listen, we talk about the hierarchy or the probability of hazards, that most likely most chemicals are going to be toxic, then they'll be flammable, then possibly corrosive, polymerized, and radioactivity. So what we did in the SOPs now, the size up, is we listed the hazards, first toxic, then flammable, then corrosive, then polymerized, then radioactivity. And we talked about underneath each one of those is the bullets to what tells you that it's flammable or not flammable. So for instance, if you look at the below the line used to be a solid, it's still a solid. All right, then it says, you know, you go down to toxicity. Since it's a solid, it's going to be toxic in milligrams per cubic meter. Since it doesn't have an IP, the PID is not going to work. So it's the same basic information, just put in a different order. So you can look at that above the line and below the line. Same kind of thing. And what we tried to do is we tried to match everything up. So what we made this year was a research form. So if you do a research form, it goes exactly by the SOG. It goes from solid all the way down to explosive at the bottom, radioactive.
So we'll bring out every class. We'll have the research form. A lot of the we've already beta tested in a couple of departments, and they like the research form so much they're photocopying it and they're putting it on their rig.
And it matches the charts.
And
they
it
use the
matches
chart.
the charts.
We've always done kind of research, but it's been in the classroom where we would ask people for answers. Now we do it in the class with a research form. Another thing that's slightly different on this one, if you go over to the Freon column, if you go over where it's fluorine on the top, where that used to only have one little slash in the fluorine
Now they're here,
to show you that fluorine paper would turn yellow if there was fluorine, like hydrogen fluoride. The F paper would go from pink to yellow. Well, what we found was that that whole Freon column is also, those are oxidizers. So if you notice on that chart, you'll see blue slashes that we only used to have in oxygen, but now we have it in Freon, fluoride, chloride, bromide, and iodine. Just to remind you, those are oxidizers also. Kind of as a review, if you look all the way to the left, those elements are water reactive. That was always on our chart, but kind of refresh yourself. Remember, sodium, pure sodium, water reactive, pure lithium, water reactive, and when they react with water, they release that hydrogen. And then if you look all the way to the right, those asphyxiant gases from helium all the way down, those displace O2 and can kill you through oxygen displacement. So that's pretty much the changes on chart number 1. Chart number 2, we've done a couple more things. For instance, what we did, if you remember, when we had the alphabetical periodic chart in the past, we would make a joke in the class that we didn't put gold on that list. Because we said, if you run a hazmat call involving gold, call us and me and Cris will clean it up for you.
For free.
But people said, well, we think, we'd get people at lunch that would count the number of elements on the chart and say, hey, your alphabetical periodic chart's not the same. So we took all the elements that are below the line, and it's now all of them listed there. Then there's thing like, you go to the water treatment plant, ferric chloride. Ferric chloride, it's kind of like saying iron chloride, but they use the name ferric. And they use cupric. And what's the other one? Mercuric.
Mercuric. Remember that when you took chemistry, that the metal was a transitional metal and the valence would change based on the non-metal? Well, we've eliminated that lecture. That lecture. We've eliminated, you know, heck, after many years of therapy, we're just going with the word. Ferric, mercuric, cupric.
So it has all that. And one other thing we put in that alphabetical list, this was probably the most common question we got. What about ammonium nitrate? So ammonium nitrate is kind of a weird one, but we know it blows up. So what we did there, it's a solid that is an oxidizer that, you know, that can blow up. So what we did is, you notice ammonium's there, and then so ammonium is, it's when we wrote on there, that's not an element. It's not really below the line, but it acts close enough to below the line that we're going to call it below the line.
Yeah, remember what I think what's dynamite about this class, what I've heard from you guys, is that you really haven't taught it till they've learned it. So if I sit here and give you, you know, college chemistry, nobody gets it. And then we run on calls. So we are a big proponent of something which is heresy in the classroom. We take liberty with the science to make the point, because the point is what saved lives. All science does is you pick up girls in Mensa meetings, but the point saves lives. There's no elements such as ferric, but you're going to respond on some type of ferric oxide. There's not mercuric, but you might do a mercuric chloride. And there's no element as ammonium, but we do run on ammonium. And we can't, so we put it there on the below the line. And you'll see later on when we chart 4 that we kind of talk about the second name, what ammonium, what the nitrates do.
So I'm going to take you to chart 3 now. So if you look at chart number 3, some of the changes we did that was, if you look at the carbon and hydrogen box, we really kind of tried to do a better job of breaking down what happens if you get a yes for a set, or a vinyl, or acryl, or propyl. And if you see yes now, it points to it's going to be number 3 through 16. If you go to the bottom of the carbon and hydrogen box where it's benzene, toluene, xylene, styrene, or cumene, BTXSC, that arrow says I'm going to family number red 2. So then if you go down there, let's look at red 3, for example, Cris.
Okay.
We kind of changed that a little bit. Remember the old chart used to say, if it ends in ANE, it's flammable and toxic. If it ends in ENE, it's flammable, toxic, and polymerized. What we did was we broke that apart. So now we call it red 3 for the ANE, red 3P if it ends in ENE.
Look at red 3. We got a red 3 and a red 3P. Red 3 ends in ANE. For example, ethane, propane. Red 3P is the same ethane prop, but now it ends in ENE, propylene, ethylene. So that's still a red 3, but now we're adding a P because that tells you that that chemical polymerizes, and we'll see in the book why.
We used to see a lot of examples in the classroom where we would run something like propane, and propane, people would say flammable, toxic, and polymerized because they see that little P there at the end. So I think this is going to make it easier to determine between the anes and the enes. And then if you go down there, another thing we did is down at red 15. This is another one that caused a lot of problems. We used to put F, and then we put Cl, Br, and I. What does that stand for? How many times have you heard that?
Right. Go to chart 1, look at the freon, look at the element symbol for chlorine. It doesn't, it's Cl, look at bromine, it's Br.
So, for example, if we ran methyl chloride now, you would have methyl, yes, in the carbon and hydrogen, and you'd look for the last name chloride. Very simply takes you down to red 15. We've seen amazing results on that.
Yeah, because the whole system is based on names, and as soon as you say it's based on formulas, now all of a sudden the brain doesn't read it. And so we said, you know what? Let's not put Cl. Let's put the word chloride. So that's the red 15.
And then if you go for across the top again, when you look at the flammable clue and you get no, you go to the corrosive gas clue, that remains the same. But if you get a yes for the corrosive gas box, you see that takes you right to red 0. And if you get a no, it points exactly to red 1. So
and the red 0, Joe, on top says corrosive gas.
Right.
And above red 1 says unknown.
Unknown. So it makes it much easier for that. Then if you look at the area where we had red lights before, you'll notice we added a whole new line of yellow lights. Dangerous, but you don't need to stop, but you better have a good reason to continue forward on that. So you can look at the yellow lights. Red lights are pretty much the same. I think we changed the red light for radioactivity. It used to be twice background, which we made into the yellow light. Now is it 5 R per hour?
Yes.
5 R per hour is the red light. Stop, because you're going to get the maximum allowable dose of radiation.
And remember, that's based on, you know, Joe's experience, my experience, and yours. You know, we'll go into some type of a flammable gas release. I'm getting 4 or 5%. And, you know, 100 times I've gotten that in my career. I'm getting 5% of the LEO. I didn't back out. I mean, I had to go in there and find out. I might have to go down underground and cap it
Chris,
off.
there's never be a natural gas leak fixed if you quit at 10% of the LEO.
So we
They'd
told
never
Joe,
be able
you
to
know,
get down
Joe,
there.
why don't we incorporate a caution? I mean, that's what we do. And he said, you know, you're right. And it took a long time, but eventually we were teaching it in the class, but now it's in the chart. So it just tells you, it's like a yellow light. So if I'm 0% of the LEO, an unknown LEO, yeah, you're under 10%, which is the action level or the red light level, but at 2%, heightened level of awareness,
Because
yellow light.
if I'm down underground and I'm like in a sewer and there's natural gas down there, you've seen it 100 times because I've seen it 100 times. It goes from 2% to 100% like that because it's a small container. So just again, that's the use caution. So that's new. Another thing that's new, if you look at red 7, we figured out that these aldehydes can also form peroxides. So we put in there that it forms a peroxide.
And so just so everyone understands, when we do research on the chart, we go to the family or go to the derivative. All right, so when Joe's talking about red 7, all right, yeah, it's aldehyde, but the aldehyde is in chemistry, you know, a certain formula. So what Joe and I do is we go into the books, we look for all the aldehydes.
Acetylaldehyde, glutaraldehyde,
all of them.
Formaldehyde, furfural, all of them.
And if one of them shows a hazard, then we put it in the family. We stick it in. It doesn't mean that all of them have the hazard. It means one of them within that family has that hazard. That way, when you're responding on the call, remember this doesn't size up. When I'm responding, worst case scenario, we will tweak this when we get to the rig and open up the book.
Here's another big change on chart 3 and 4, the PPE column. If you look at the PPE column, we always talked about mission-driven PPE. So what we did is we broke the columns down into the missions. So if your mission was rescue or your mission was plumbing, and what we do is we recommend it. So if you see TO listed first, that means turnout gears are number 1. Then if it says B, and then it says A, well, the next one would be level B. So if I didn't have turnout gear, but all I had was level B, say I work for the EPA, guess what I'm wearing? Level B. I go to the military. Some of these military groups don't have turnout. They don't have level B. They have only level A. So guess what they're wearing? So what we did is we put the list of what we recommend, but it's really based upon what you're carrying with you. And then you think about your mission. Is it rescue or is it plumbing? So that's what that whole column covers.
And just to add to that, because you don't have that chart, this is a brand new chart. This is basically
probably going to come out May 1st.
Yeah, this is a world premiere. If you're looking at this video now and you don't have the charts, don't feel left out. This is the 20th version of 10 years of working on charts, and this is the best one.
Yeah, I agree.
This is the best one. So under mission-driven PPE, you'll see that the column is rescue recon. Because when you do a primary search on a house fire, if you're going underwater to do a primary search inside of a car or a vehicle, if you're going to the confined space or a hazmat in a warehouse, I'm doing a recon to see if this is a rescue mission or a plumbing mission.
So recon always comes before rescue. So that's why it's recon rescue.
And then the other one is plumbing identify. Plumbing means basically pig putty, you know, soap. It means overpack drum. It means neutralization. It just means the act of removing the hazard from the immediate area, from the environment. What's the identify? Bringing out the instruments, like show them back there, Joe, a couple of those instruments. The instruments that tell you not what the hazard is. You already got that with the LEL sensor. What's the actual product?
This is, what's the name of the chemical? You know, you spend $40,000, $50,000, you get the name using these instruments. So that's the same category as mission-driven. That's the same category as doing plumbing in the mission-driven PPE.
Now, why does that instrument come last? You say, well, why wouldn't you do that first? Because it's not intrinsically safe, man.
Hazard identify, chemical identifier.
Yeah, we've been to a
in
lot of
that
military
order.
classes where they're going into these HMEs, terrorist explosive labs, where they're using flammable liquids like acetone to make a certain, like TATP, and they're using a laser.
Non-intrinsically safe.
When acetone's flash point is 0 degrees Fahrenheit.
So that could turn out to be the ignition source.
Yeah, you're right.
Yep. Okay, so that's chart 3. If we go to chart number 4, which is the below the line, again, the first name elements are the same as we put on chart 2. So all of them are there. The ferric, the cupric, and the mercuric are there. Ammonium's there. But we added a new family or 2 down there because we get this a lot. Hey, what if you ran a spill of this dangerous chemical called sodium chloride? We never had sodium chloride on our chart before. But what we did, if you go all the way down to the bottom to a blue 15, that's kind of like the below the line freon family. So you could have sodium fluoride, sodium chloride. So that would be there. And then our HME buddies said, hey, why don't you guys have something like fulminate, mercury fulminate, super explosive compound. So what we did on the blue 14 is we came up with fulminate. So fulminate's just another explosive on the chart. The PPE is the same as chart 3. We put it in the hierarchy based on the order based on your mission. The red lights and the green lights remain the same. So everything else there is the same.
Oh, the blue 11, minimum explosive concentration.
Yes. If you go to blue 11, that used to just be for the oxidizers, ATE and ITE.
Look up zinc stearate. If you look up zinc stearate, you'll see zinc is below the line. It'll take you to chart number 4, and it's an ATE. You go to blue 11, and it says, hey, if you're in a blue 11, and it happens to have carbon and hydrogen, that's what's in the hazard box. This is here in the cheat sheet, in the charts. And it has carbon and hydrogen, that equals MEC. Well, what's MEC? If you look in the zinc stearate, for example, or sucrose, if you look underneath the LEL, you'll see minimum explosive concentration.
For dust explosion, how much dust does it take to blow up? So how would you know it? I'm a below the line that's got an oxidizer, and it also has C and H in the formula.
That's new to the charts. And the reason blue 15 has all 3 colored X's, the pH papers and the F paper, is because, for example, rat poison, sodium fluoride. If I put an acid on sodium fluoride, it'll release HF. Now, how would you know that? Put an F paper over the reaction, it'll turn yellow. So the F is released from the sodium fluoride.
Okay, so then the next thing we did, remember we used to have the system that the top part of the system was for known chemicals. The bottom part we would run kind of the opposite way, and that would be for unknown chemicals. What we did now is we made chart 5 and chart 6 specific to known chemicals is 5, unknown chemicals is 6, and it really breaks down each step of the system. Still a 4-step system, still size up, still verify, still choose meters and PPE, and still go into the hot zone, but it's way more specific on how do I do step 2? Where do I look in the book for step 2? What meters should I bring? And then based on your mission, how do you make it safe? What are you willing to risk your life versus not risk your life?
But that's on the research form that we're now passing out.
Right, exactly. Then if you go to chart 6 is for unknowns, right? You can't go to the book and look up hazards of an unknown. What page is the leaking drum in your NIOSH? You don't have leaking drum. So how do you come up with hazards when it's an unknown?
Meters.
Meters. So what we have is step 2 now is meters.
Yeah, so listen, guys, it's no different than responding on an unconscious patient. When a patient can talk to you, you can ask him where it hurts.
That's like the book.
Right, they're giving you information. If the patient's unconscious, I need meters. Put on the oxypulsimeter. Look at the pupils. Let's look at the heart rate. Let's take a pulse. Feel the carotid. Maybe we can find out what the systolic and diastolic is based if I can't get a carotid, can I get a femoral? Can I get a brachial? So that's all this is. There's 2 ways to get information. In the cold zone, when you have a name. In the hot zone, when you don't have a name. With meter reading.
Exactly. So if you look at chart number 6 that has the unknowns, what it says is, I'm going to take these meters, I'm going to decide what my mission is in step 3, and then in the hot zone using those meters, it's what are the hazards. So it's just a different way of coming up with hazards. Again, it explains how do you know if it's toxic in the air, how do you know if it's flammable in the air. So it does a real good job of explaining what the meters are telling you.
We talk about 3 kits. We talk about the safe kit, the tox kit, and the ID kit. They're all behind us. So, you know, in other words, just like we got hotel packs, just like we got trauma kits, just like we got med kits, the med box, the trauma box, the hotel pack. Well, what we did, we took that thing that works in the fire service, and now we put it on hazmat. Get the safe kit, Stay Alive 5 equipment. Get the tox kit, parts per million equipment.
The toxic meters.
The toxic meters.
And
Get
then
the ID kit.
That's that stuff back there, yeah.
That identifies it.
So that's chart 6. Then what we did on chart 7, that's kind of like, remember from the older charts, the ones that the information that we predict you're going to forget.
Yeah, that's what I like to call random thoughts of a cluttered mind. That's all the shit that you need to know, but there's no reason to remember it. But it'll save your life if you have a place where to go.
And it's laid out just like the rest of the charts are, based on probability of hazards, toxic, flammable, corrosive, polymerization. It tells you all that. Solubility, we get a lot of questions on solubility, so we kind of drilled into that a little bit more. Toxicity, the rule of 1300.
The rule of 1300.
1% equals 10,000, that information there. Then meters. We're always big on interpretation of meter readings. So what we put there was the meter, what hazard it measures, what is the unit of measurement, because they all can read 10, but the better question is 10 watt. And then when do I need to get out based on red lights? So that's a great little chart there. And then the last thing was we really wanted to do a better job of explaining when do you wear certain PPEs. So we broke down chart number 8 into level A, level B, level C, and level D. Or I mean turnout gear, not level D, turnout gear. And what we put is we described what it is first. Then what we put is indicators. When do you wear it? The next column says when do I not wear it? And then when I'm wearing that PPE, what are my red lights? Mm-hmm. So that is awesome information.
That's new. That chart's new.
That whole chart is brand new, right? Mm-hmm. On how to choose the correct PPE. And if you look at I'm wearing a level A, all you got to do is go to the limitations of level A, and it says don't wear it in flammables. Well, if you're going on a flammable, you just chose the wrong PPE. So that helps you a lot when it comes to choosing PPE. We're rolling out a whole new class based on this. It's called HazMatIQ 2.0. New chemicals, new charts, new information. So hopefully we'll see you guys in the last year. My buddy here, Cris, and I, we're kind of on the last ride. We're retiring after this year. So if you want to see me and Cris work together, you got till January 1st, 2018, and we're hitting the highway. So if we don't see you the next year, you're a loss. But hopefully we'll see you in the next year.
I love you guys.
See you later. Hey, thanks for everything. It's been a great ride.
Thank you.